Hello, and welcome to Lesson 4 of You Can Do Math. This one is division. So division is just the opposite of multiplication. In multiplication, it's a method for adding up rapidly groups of equal size. So for example, if I have 3 groups of 3, that's the same as 3 times 3, right? So 3 groups and 3 in each group. So that means we have 9 things total. And in order to do division, you must first know your multiplication tables by heart. There's pretty much no other way around it. So if multiplication is adding up groups of equal size, division would be taking a group of items and dividing them into groups of equal size. So if I have, say, so here we have 10 items. Suppose I wanted to divide these 10 items into 2 groups of equal size. So that would be 10 divided by 2. So this symbol with a line and a dot above and below, that's our division symbol. So what would that be? Well, using the picture, since I have 2 rows of 5, I could guess that. So here's one group of 5, and then another group of 5. Put them together, that would be 10. So if I divide 10 into 2 equal groups, there will be 5 in each group. So, and if you know your multiplication tables, you can see immediately that since we know that 2 times 5 is 10, that means if we divide 10 by 2, we're going to get 5. So it's related to the idea that 2 times 5 is 10. 2 groups of 5 in each group gives us 10. So that's the idea there. And, I suppose using the same idea, so if I had 10 items again, let's say that this time instead of dividing them into 2 equal groups, I want to divide them into 5 equal groups. Well, to do that, if we think back to our multiplication tables again, we know that 5 times 2 is 10. So if I have 5 groups with 2 in each group, that gets me to 10, right? 5 groups of 2 in each group is 10. So that means that if I take 10 and divide it into 5 groups, there's going to be 2 in each group. So there's 1 group, 2 groups, 3 groups, 4 groups, 5 groups. So we have 5 groups, 2 at each group. So that's how we would divide 10 into 5 even groups. So that's basic single-digit division. It's pretty straightforward. If you know your multiplication, as I said, if you know your multiplication tables, it should be a piece of cake. After that, we have what's called long division, which is a little trickier. Not too bad. So suppose instead of something that goes straight from a multiplication table, we had something more complicated. Suppose I had 10, or sorry, let me rephrase that. Suppose I had 162 divided by 2. What would that be? Well, first, So to do this one, we need to do long division. So first, the number we divide by, we put out here. The number we're dividing goes in here. And then we look at we do the numbers one at a time. Can 2 go into 1? No. So we put a 0 there. Can 2 go into 16? Yes. So it would go in there 8 times, right? Because 8 times 2 is 16. Put a 0 here. Bring down the 2. How many times can 2 go into 2? Well, it can go in there 1 time. So our answer then is going to be 81. So 162 divide 2 is 81. So the trick here is when you're looking at the numbers, you want to try and think of a number that if you multiply by the number, you want to find a number where if you multiply these two, you get whatever this one is. So it's kind of a guessing game. And if you know your multiplication tables, it's not too bad. Suppose we have, say, 4 into 39. 4 won't go into 3. So put a 0 there. How many times would 4 go into 39? Well, let's see. 4 times 8 is 32. 4 times 9 is 36. And 4 times 10 is 40. So the closest one there would be 9. It would be 36. I suppose I should say at this point, you want to get as close as you can to the number here without going over. So the closest we can get to 39 without going over is 9 times 4. I'm going to stop here because at this point, this is as much as we can do. So since 4 cannot go into 3, we call that the remainder. So our answer is going to be, so if I say 39 divide 4 is going to be 9 remainder 3. And we'll talk about how to deal with remainders in a few minutes. I suppose I should try a 2-digit one, or so we have 25 going into, I don't know, let's say 625. So how many times can 25 go into 62? Well, if you think about it, you can think of it maybe in quarters. It's a little easier. So a quarter is 25 cents, 2 quarters is 50 cents, 3 quarters is 75 cents. So since 75 is too big, it would have to be 2. 2 times 25 is going to be 50. I'll bring this down here 12. We bring down 5. Okay. So again, thinking about quarters again, you can think of this as $1.25. So that $1 is 4 quarters, and then 25 cents would be 1 quarter more, so that'd be 5 quarters. I kind of ran out of room here, but this works out evenly to 25. So 625 divide 25 is 25. No remainder there. So long division takes a little practice to get good at, but it's not too bad. Work a couple more examples before moving on. If I have, say, 7 going into, I don't know, say 62. 7 won't go into 6, it's too big. Put a 0 there. How many times would 7 go into 62? Well, let's think. 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. So 9's too big, so we'd have to put an 8 here. 8 times 7 is 56. We would have to borrow 1 here. So there's a 5. This would become 12. 12 minus 6 is 6. So our answer would be 8 remainder 6, which we could rewrite as, suppose you'd write it like this. And one more like that. If we have, oh, I don't know, 12 going into, say, 50. 12 won't go into 5, so that would be a 0. We don't technically have to write the 0, I was just doing it up there to make it clear. So 12 won't go, it won't go into 5. Does it go into 50? Yeah. So we would say 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, 12 times 5 is 60. So since 5 times 12 is too big, it would have to be 4. 10 minus 8 is 2. So our answer is going to be 4 remainder 2. Okay. We'll revisit long division in a little bit when we talk about decimals. Not in a little bit, but in a future video. And what dovetails or fits in nicely with division are fractions. So fractions represents part of a whole. W's are always a little messy. So we're talking about numbers less than 1, usually. So a classic example of this is if you have a pizza and you divide it into 8 equal slices. Each slice will be 1/8 of the pizza. I guess I should say the. So we're only talking about one pizza here. So fractions are pretty simple. So on top, I suppose I should start talking about numerator and denominator. I think that's not really necessary to introduce that much terminology. But going back to our pizza example, let's say we had only 4 slices on our pizza. If we had only 4 slices, each slice would be 1/4. Okay? Or another way you could think of it is if it's the same idea of a pizza and you have, say, 2 slices, that would be 2/4, right? You have each slice is 1/4 and we have 2 of them, so that would make it 2/4. So what happens when we have fractions where the number on the bottom is different? So suppose we had 1/4 plus 1/5. How could we add those together? Well, to do that, we need to rewrite both fractions so that the number on the bottom is the same. So what will always work is to multiply the first one by the number on the bottom here. So for example, call that it would look like this. Or maybe I shouldn't use parentheses yet. I should use the multiplication symbol. Now, we know already that 5 divide, I guess I only need one x there, do it like that. A number divided by itself is 1. So what I'm really doing here is multiplying 1/4 by 1. So that doesn't, it's a legal move, it doesn't change anything. Do the same thing over here. And so what we end up with is 5/20 plus 4/20. Since they have the same number on the bottom, I can rewrite both these as being over the same denominator, it's called. So that would be 5 plus 4. I'd have 9/20 is my answer. I wanted to add, say, or I suppose I could do something like 2/3 plus 3/4. Again, you multiply this side on the top, you multiply this one on the top and the bottom by this number here. So that would be 8, 9, 17. So we could write this as 17/12. So when the number on top is bigger than the one on the bottom, that's called an improper fraction. It's okay in most cases to leave it like this, but another way to write it would be as a mixed number. So this would be the same as 12/12 plus 5/12. So maybe I should right? 12 and 5 is 17. So 12/12 is 1. So our answer we can write is 1 and 5/12, like this. And this is called a mixed number because it has a whole number and then the fraction next to it. So now when we know a little bit about fractions, we can go back to talking about how to deal with that remainder again. So if I had, say, 8 and 33, 8 doesn't go into 3. It goes into 33 4 times, right? 8 times 4 is 32. So 1. So this would be 4 remainder 1. Now what this actually means then is this remainder gets divided by this number out here. So 4 remainder 1 in this example really means 4 and 1/8, right? Because 8 is our divisor, this number. So I can say, so this is what the meaning of remainder is. It's really the fractional part of the answer. I'll do another example like this to drive the point home. If I have 7 going into 46, okay. 7 times 6 is 42, 7 times 7 is 49, so 7 times 7 is too big, it's got to be 6. So this means that we take this remainder and we divide it by the number on the outside, so this would be 6 and 4/7 is our answer. So that's how we deal with remainders. Now on a calculator, if you punched in this, you would get a decimal, but we haven't learned about decimals and how to convert between fractions and decimals yet, but we'll be getting to that in not too long a time. So to summarize or review, when we divide, we're taking a group of items and dividing them into groups of equal size. So I suppose the last thing I'll finish up with is we'll just do a little word problem. So we say, suppose you're entertaining some friends, or you want to give some kids some cookies because you're a nice person. Okay, so the answer to this, we have 40 cookies, and we're dividing them equally among 10 kids. 10 doesn't go into 4, it goes into 40 4 times. So each kid's going to get 4 cookies. Okay, well, that's the end of the lesson for division and fractions. And for the next one, we'll be moving on to decimals and how to convert between fractions and decimals.